Okay, good afternoon, everyone. Welcome to this session by a fellow colleague. Gasper is going to tell us on how to do effective analytics with FHIR Server. There will be 15 minutes of presentation and afterwards 5 minutes to ask your questions, so please reserve them for afterwards. Okay.
Thank you. Welcome, everyone. Who am I? I'm Gasper. I'm from Slovenia. I'm a FHIR Server technical consultant. Meaning that what I do is I help our customers and clients set up the FHIR server in their existing architecture in a way that it can really play an active role in the data exchange. And why I say this is because this is also the foundation of my talk. I'm going to talk about a specific use case of how we had to leverage components outside of the FHIR server to suffice the analytics use case of our customers. Let's look at the objectives. We'll talk about the FHIR server peripherals. So even though the primary use case would be analytics, really the architecture that I'll describe today and also the capabilities of the FHIR server could be used to suffice any other integration as well. The specific use case that I'll mention is integration of the FHIR server with Elk, so Elastic, Logstash, and Kibana. But there is a bit of a disclaimer here. So this is not a SQL on FHIR talk. There were plenty of that during the week. This is really for a simple analytics use case that our client had to support, and not a complex one where the whole relational database and those kind of complex queries would be required. And where do I come from with this problem, or why we had to set this up in the first place? Basically, the use case that we had was hundreds of hospitals and systems storing data to our production FHIR server. And then the client came with the idea that they would want to do analytics on this FHIR server and run some complex queries that were not supported by the, so to say, FHIR spec, and therefore also not by the FHIR server. And those are kind of queries where the fields would not be indexed on the database level, and therefore the performance of this FHIR server running in production would be impacted if these analytics would be run directly against the database. So I would like to establish a clear idea of separation of concern when something you would need to do outside of the FHIR server, not to have the primary use case of such a FHIR server impacted by your secondary use cases. So really, as soon as you see something that would impact the performance or in any kind of way affect the primary data flow, perhaps it's good to look outside the box and see what kind of integrational capabilities there are. So once we have established this separation of concern with the client, and once we have gotten the client away from the idea of running this against the primary FHIR database or through the FHIR API, we had two approaches. Or maybe we had more approaches, but the two approaches is what we really looked into. And the first approach was this. So let's say you have a system producing FHIR data. The FHIR data goes against the FHIR API and is persisted inside the FHIR database. And this flow is not impacted but by what happens then in parallel. So alternatively, what happens is this, what we see on the left. Oh, this is quite big. On the left-hand side, and the whole thing on the left-hand side happens asynchronously, meaning that the performance of this flow is in no way affected by what is happening there. So FHIR server offers this really cool framework, the plugins framework, where you can basically hook into any phase of an HTTP cycle and do any kind of business logic you would want to do by executing your piece of the code. There are lots of plugins already available, and you can just use them if they suffice your use case. But really, if they do not, and for this specific purpose, we didn't have an already available plugin. We wrote basically code that did some stuff, and this stuff is then this thing. So what we implemented in analytics plugin was some kind of data processing, which means that we really prepared the data for the analytics use case and persisted that data to a secondary database. Now that secondary database could be FHIR, but also is not necessarily FHIR. And in our case, we actually did not want it to be FHIR because we really wanted to minimize the required payload to the bare minimum to suffice the analytics use case and not have all the bloated metadata that the client or the analytics use case really didn't require. So we wanted to minimize also, be cost aware, so we didn't just duplicate everything that was happening here, there, but really in the analytics plugin, did the massaging of data and preparation of data that then ended up on the inside the secondary database. And again, this whole thing had to happen asynchronously in parallel already when the system that produced the data in the first place have gotten a response and was not affected by the business logic there. In our case, there really wasn't complex business logic that would have any kind of performance impact, but it wouldn't matter in any case, because that is a fire and forget action from this whole data flow. And then the possibilities from there are kind of endless, really, because all the data that you have separated there. Whatever complex SQL queries or whatever you would do there would have no impact, as mentioned on here. And then you could put a UI on top. You could put even this architecture could even be used to prepare the data here to be SQL on FHIR compliant, and then do SQL on FHIR here. So really, whatever happens there is there completely in the domain of the analytics team or whoever is in charge of that use case, and it does not affect the primary goal that the FHIR server should have. But you know how we are, we don't want to reinvent the wheel. If tools are already available, we want to use those tools. So the second approach was actually proposed by the client, because the client was already using components of this ELK stack. So Elastic, Logstash, Kibana, which are the tools designed specifically for visualizing and analyzing large volumes of data. And the good thing here is that this is very easily integratable with out-of-the-box functionalities of the FHIR server. So if with the previous approach we actually had to do some coding to write that plugin, here it leverages existing functionalities and it does not require to write any kind of code or in any way extend the FHIR server. So again, what we have the server that is accepting the data from the system at the top. And here it leverages MongoDB change stream functionality, meaning that there is an event listener within the FHIR server core code that listens to changes on the database level. Change is, of course, as well something when something new gets ingested there, and that change is then, so the event listener listens to those changes and then pushes those changes to a messaging queuing system. It could be Kafka, it could be RabbitMQ, but the fact is that whatever is changed in the database is then published to this queue. Now this is configurable whether really the whole payload is published to the queue or just the fact that something has changed, and then you could also go back to the server and fetch the change thing. But in our case, we actually wanted the whole thing to be pushed to RabbitMQ, because in the next step is where the data processing would happen. So on the other side of the queue, we set up Logstash that was subscribed to this queuing system. Whenever something ended up in RabbitMQ, Logstash would be polling from it, and the Logstash is there for data processing, which means data anonymization, pseudonymization, enrichment. It is a really, really powerful tool, and it allows really cool filters. For data enrichment, you can even have connection to an outside database to enrich the data before it is being used for analytics. You can do all kind of you can even execute code on that data and really prepare the data for your use case of analytics. But there is one major pitfall, or why I mentioned that this approach is not a SQL on FHIR one, is because this does not mean that you're exposing or preparing your data in a relational database. So Elastic, that is on the other side of this, so Logstash then pushes to Elastic, but this is still a document-orientated persistence layer, meaning that you cannot, for example, then run analytics like give me all patients that have at one point in time been consuming some specific medication, because then you have to write SQL queries to really link the different types of resources. But it was sufficient enough for our client and our use case. And then again, this is where imagination can go wild. So once you have things in Elastic, you can put Kibana on top, which is meant for visualizing of this data. So to summarize what we have achieved, so FHIR server out-of-the-box functionality to push the changes to RabbitMQ, Logstash on the other side for data processing, Logstash then pushing data to Elasticsearch, and Kibana on top. And then I'm in no way a professional for Kibana because this was already in the domain of the client. But what you can then have are this really nice visualization. So say that I'm interested in which system was producing the most data for whatever billing purposes or something. No, this is really tiny, but you can have all of these nice things then, and maybe adding medication on top. And then you can see exactly what kind of medication was being produced by some specific system, etc. So again, I was just playing around with this. I know a lot of this is possible, but it is then this in the domain of the analytics team to make use of these tools. Now if we go back to the presentation. 1 second. But yeah, as mentioned, so analytics is never just that simple, what was, although sufficient for our client and our use case. But if there is a requirement to run complex, like quote-unquote proper analytics, then maybe SQL and FHIR is the way to go. But the good thing is that, as I have mentioned with the first approach, it is very easy to separate the data and the analytics case from the primary stream of data and really use the FHIR server for what it was meant to be used and not abuse it for other use cases that could impact performance. And this is also the key takeaway, really to use the tools and services for what they were meant to be used and leverage integrational capabilities of the FHIR server. And this is not limited to FHIR server. I know Happy also offers several kinds of interceptors and lots of other probably servers as well. Thank you. Any questions?
Are there any questions? Thank you, Gasper. Matt.
I probably could ask you this at another time, but now I'm curious. When you put it into the Kibana, are you keeping it as a resource and it's able to read that for the analytics, or are you parsing it further down?
No, so the whole preparation of data and parsing from the resource is happening in Logstash. And then the relevant data is being pushed to Elastic, and the analytics is then run on the Elastic.
What kind of format is it when it goes to Elastic?
You can do anything, but it is a key value field, so to say. But what you can also do in Logstash is to just say, I'm going to take the whole resource, and I'm going to treat the whole resource as key value pair, and then it ends up in that way in the document in the Elastic. But that messes up the dashboard a bit, because then you have really nested JSON paths in there, and that messes it up a bit.
Thank you. Any other questions? Everything clear? Otherwise, don't feel shy to walk up to Gasper after this session to ask your questions, or contact him through his email. And then I would like to thank you.
Thank you.